Charmander is orange, Charmeleon is orange, Charizard, orange, Mega Charizard Y, orange, Gigantamax Charizard, orange, Mega Charizard X, or blue. What? Why? No, it's not because the Megas are complementary colors, otherwise Mega Mewtwo X would have been yellow. No, it's because Mega Charizard X is actually 1,000,000% more powerful than all its other forms. Let me explain. Part 1. Flame Colors. The Pokédex entry for Mega Charizard X states that the overwhelming power that fills its entire body causes it to turn black and creates intense blue flames. We'll work through this entry in reverse order, starting from its ability to create intense blue flames. What gives a flame its color? Flames are the colors that we see from a fire. In other words, they are the light emitted from fires. A fire is formed when oxygen in the air reacts rapidly with a fuel in a process known as combustion. This process requires heat to break the bonds in the fuel and oxygen, allowing them to release massive amounts of energy as they transform into new compounds. This is why Charizard's tail shouldn't be immersed in water for too long, as water can absorb heat, displace oxygen, and prevent the continued vaporization of fuel. The flame on Charizard's tail is the same color as most natural flames we see. Whether it's from forest fires to candle flames, these fires typically have one thing in common: the kind of fuel used to make them. Whenever a fuel made of carbon is burned, such as a hydrocarbon like methane, carbon dioxide and water are produced. However, if there is not enough oxygen, incomplete combustion products can be produced. Among them, soot, which is just fine unburnt carbon particles, can be released into the air. These particles emit light due to their high temperature in a process called incandescence, which we shall explore further in a moment. The end of Charizard's tail is very small. As a result, the rate of combustion at the tail tip might exceed the rate at which oxygen can mix with the fuel coming out of the tail. This would result in incomplete combustion and the formation of incandescent soot. The temperature of such a flame would still be enough to melt glaciers, but it is highly inefficient. For instance, the maximum flame temperature of most natural materials, such as wood, is around 1000 degrees Celsius. During incomplete combustion, this can be reduced to 600 degrees Celsius, resulting in more reddish tones in the flame. What about when Charizard gets really fired up and can generate a blue flame? Part 2. A black body. I mentioned earlier that incandescent soot particles glow yellow. This only happens when incomplete combustion takes place. For example, a Bunsen burner would burn with a yellow flame when the inlet is closed due to soot formation, which indicates the relatively low temperature of the flame. This incandescence is also clearly visible, which is why it is called a safety flame. On the other hand, if the inlet is fully open, allowing oxygen to mix thoroughly with the gaseous fuel, complete combustion occurs and no soot is formed. No incandescence takes place. Instead, the temperature is now hot enough to excite particles in the air and form free radicals, which you can think of as highly reactive, unstable molecules. When these particles emit light, it is called chemiluminescence. There's just one problem though. Chemiluminescence might require high temperatures to work, but it doesn't actually release that much heat. This would fit regular Charizard, as it can produce a blue flame if it's agitated, but we need a more compelling mechanism for Mega Charizard X. The Pokédex entry claims the Mega Evolution power turns its body black and not blue. This is not an error. A black body is a scientific term which refers to a theoretical object that absorbs all light that falls on it. This also means that a black body would emit radiation when it's in thermal equilibrium with its surroundings, known as black body radiation. In other words, the design of Mega Charizard X hints towards the idea that the color of its flame is due to black body radiation and not incandescence or even chemiluminescence. This is a fine approximation since normal matter emits black body radiation, just not optimally. Okay, so what, you may be wondering? Look at these two charts. The top one is a blacksmith's color chart. Blacksmiths have used it for centuries to read the temperature of a metal just by eye. The hotter the metal, the closer to white the color gets. Natural flames behave in the same way. The bottom chart shows the color of stars depending on their absolute temperature. For example, 1000 Kelvin is equal to 727 degrees Celsius or 1340 degrees Fahrenheit. When a body emits black body radiation, that is almost exclusively due to its temperature. So that means Mega Charizard X must be around 10,000 Kelvin, which is roughly 10 times the temperature of an orange emission. How does it provide the overwhelming power to boast temperatures rivaling stars hotter than our sun? Part 3. Extra hot. This is the Stefan Boltzmann law. It allows us to quantify exactly how much power is overwhelming. For instance, let's calculate it for the lukewarm Charizard first. We already saw that Charizard's flame is due to the incandescence of soot, which occurs at a temperature of roughly 1000 degrees Celsius. However, when we work with equations like this, we need to convert to absolute temperature, measured in Kelvin, where 0 represents the complete absence of thermodynamic temperature and heat. 1000 degrees Celsius is approximately 1300 Kelvin, but we'll round it back down to 1000 for simplicity. If we assume that the tip of Charizard's tail does not change size during Mega Evolution, we can calculate the ratio of their temperatures to determine how much more powerful Mega Charizard X is. The difference between 1000 and 10,000 Kelvin is obviously a 10x increase. However, in the equation, the temperature is raised to the 4th power, which means we raise that 10x increase to the 4th power. That results in a power jump of 1,000,000% or 10,000 times. Suppose Charizard was able to melt a glacier in 1 hour. Mega Charizard X could melt the same glacier in the time it takes to blink. Blue stars, known as B-type main sequence stars, are approximately 2 to 7 times larger than our sun and reach the temperatures needed to glow blue-white. Meanwhile, Mega Charizard X is the height of an average teenager, which is 1.5 billion times smaller than the smallest B-type star. That's like comparing the size of a pea to that of the entire Earth. One small problem, or maybe it's huge depending on your frame of reference, the bigger the star, the brighter it gets. That's because bigger stars deliver more power as a result of more nuclear fusion. Part 4. Plasma power. How can something the size of a Charizard have any chance of delivering overwhelming power? Thankfully, the answer does not depend on the size. The Stefan Boltzmann law tells us the power per unit area, not total power. So, if Mega Charizard X's flame reaches 10,000 Kelvin, every square centimeter of that flame is exactly as intense as every square centimeter of a B-type star's surface at the same temperature. To reach this temperature, Mega Charizard X exploits the practically infinite energy of Mega Evolution. to ionize its combustion products into a plasma, allowing it to surpass the temperatures of regular fires. Incidentally, this makes Mega Charizard X more similar to Zekrom and Black Kyurem than to its other forms alongside its dragon typing, but that's a video for another day. Let's return to where we started. The overwhelming power that fills its entire body causes it to turn black and creates intense blue flames. That should no longer come across merely as a poetic description. Instead, it's a sequence of scientific phenomena that explains how Mega Charizard X has mastered its offensive prowess. Mega Evolution channels a power so overwhelming that it ionizes Charizard's combustion products into plasma, allowing it to surge beyond any temperature achievable by ordinary fire. At 10,000 Kelvin, the body absorbing that energy turns black, becoming a near-perfect black body. In addition, the flames it produces radiate with the same intensity per unit area as the surface of a blue B-type star. In summary, blue was never meant to be a cool color according to science. That doesn't stop Mega Charizard X from being the coolest in my eyes.